Good morning, students. Today we'll discuss about this continuous casting process. Earlier, we have already made the steel in different furnaces. So then we'll go for solidification of this steels into ingot. Uh, so there are two types of casting methods. One is your conventional casting, another is continuous castings. So the conventional casting is a that is very costly, and the cost of production is high, and this is a continuous casting is a modern development. So before discuss about this continuous castings, we should know what is the ingot. Ingot is a shape which is obtained from the trimming of liquid metals through the ladles and tundis to the ingots to the mold, and we will get the ingots. So this liquid steel is poured into a mold. To this mold is made of cast iron, and we will get a ingot from this mold. So before then this mold will go, this ingot will go to different rolling mills. There are two types of rolling mills in conventional rolling mills. In conventional ingot castings, there are two types of rolling mills. One is primary rolling mills, and another is your secondary rolling mills. In primary rolling mills, so generally what we product we obtained is blooms, slabs. Then that bloom and slabs uh, again go to the secondary rolling mills where we will get the finished product. So this is your secondary rolling mills. First is your primary rolling mills. This is your secondary rolling mills in conventional ingot castings. So in secondary rolling mills, what we will get, that is we will get a flat, again plate and sheet. All this product we will get sheet, and again this primary rolling mills we will get bloom and slabs. So these are the different products which we are getting from this primary rolling mills and secondary rolling mills. But in continuous castings, we are directly get the slabs. Directly we can go to the thin sections of the castings. So this is a advanced process. So in this process, we are eliminating this primary rolling mills. Mostly we are eliminating this, and we are getting directly we will get the slab, and then your finishing product. Then we will get the finished product. So this this conventional rolling mills or primary rolling mills is very difficult one, or more costly, and it has different disadvantages. In that case, what we will get now in conventional castings, the your metallic yield is very less, cost of production is high. The 2 points, one is cost of production is high, cost of production is high, and 2 is your metallic yield is less, So these are the two disadvantages, because a separate shop is required for the conventional castings. So for this crane and ladles, all these are extra things which will add the cost of the production. To avoid this, we have come to the continuous casting, where the casting is continuously done. So what is that continuous castings? Continuous castings, then we will go to its principle. So in the principle, what is the continuous casting and its principle? This is actually that is a mold. This is a one mold, and the metal is poured directly from hot metals, and it is directly converted into the your slabs or billets or whatever it may be. It will directly cast. So what is the principle? It is defined as trimming of liquid metal in a short mold. This is the mold. This mold is short, very small mold. This short mold, and here water is injected for the cooling purposes. In these sides, water is injected for the cooling purposes. So with a false bottom through which partially solidified ingot is continuously withdrawn at the same rate at which metal is poured. So the rate of pouring of metal, so the rate of pouring of metals is equal to the rate of withdrawal of the metals. So in this way it is so much balanced that we will get a ingot which is withdrawn from this mold. So there will initially first we will provide a dummy bar, then that dummy bar will be drawn. So then the metal will continuously the metal will be withdrawn. So here in this process, what happens? This is the skin of the this is the solid skin of the ingot. So this portion, which has been shown by the scratch by hatch line, this is your solid portion of the metals. So you see the metal is, you see how the metal is withdrawn, and this is the liquid steel, which is high temperature material. That means around 1000 degree or 1500 degrees. See, at that, this is a liquid steel metals. So you can imagine how the solid skin, initially a solid skin is formed, then that will be withdrawn. So it will, this liquid steel will give a pressure on this solid skin. So that solid skin should be sufficient enough to resist the pressure of the liquid metal. Otherwise, they will be crack and a surface ruptures will come in the solid surface. So to avoid this, there is a theory. That is called your one again, that principle is there. So on which basis this theory is sustained, and the metal is withdrawn from the solid. So this is your primary cooling. This water is injected through this mold, and then when it will come out, then there will be secondary cooling methods where we can cool the ingots. So these are the two methods. So what are the equipments required for this process, continuous casting process? One, first is your ladle is required. Ladle means where the metal to be hold. When we will tap from the furnace is hot metals, then that will be hold in a ladle. Ladle is around 2 ton, 3 ton like capacity. So in that ladle we will hold this steel metals. Then we will go to tundis. Tundis, metal is poured from the ladle to tundis. Tundis is nothing; it is a just intermittent holder where the metal is poured, and it will control the speed of the metal timming. So here the metal is poured from through a tundis. Tundis just controls the speed of the metals. So speed of the hot metals. So that is a controlling mechanism to control the fluidity and speed of the metal pouring. So metal always poured from ladle to tundis, then to mold. So when the metal is poured in through this, there will be a cooling arrangement. This is primary cooling, this is secondary coolings, and this is your secondary coolings. In this way, the solidification will be formed. Then the total ingot will get solidified. Then it will be cut into different shape. And it will transfer to different portions. As discussed earlier, we have discussed regarding the pouring of the metals into the mold. So here what happens now, this uninterrupted pouring from the metal is poured from the tundis uninterruptedly, continuously it will be poured, and the withdrawn will be similarly continuously, so that So a continuous casting will go on. The casting will go on continuously into a single piece. So there is no problem to break up the pieces. It will continuously single casting will take place. So here what happens now, this layer, this is your the ingot, this is the solid, and this is the skin of the ingot. So here the ingot of the skin is formed such a amount or such a thick that this will sustains this pressure of these hot metals. So how it will manage or it will design in such a way that this metal never punctures out of this ingot skins, or this ingot skin will give a sufficient pressure to sustain these liquid metals. So this is totally a mold is designed in such a way that the pressure is properly maintained and the thickness of the skin also is also maintained. So this is the main principles. Then what happens here, you see this is a solid portion adhere to your mold walls. So that is called seal of the that is your that is the seal, the metal seal. So this metal seal is continuously moving. This is continuously moving this metal seals, which that is called a solid moving seal, which is continuously maintained in a solid piece, and it is continuously moving such that there is no crack is take place, no metal is teared into the outside the your thick skin further. So this principles, there is a movement of this mold. The mold is also moving in a ratio, that is 1:3. That is mold wall is moving downwards and upwards. So for the stripping of the ingots, so there is a principle that is called Jung-Hwang's principle, in which the movement of this movement of this mold wall and the movement of this ingot, there is a correlations for obtain a good continuous casting without the crack. So what is that? That is that stripping mold stripping downward speeds. So the downward speeds of the mold should be downward speed of the mold should be greater than the withdrawal speeds. This speed again that should be greater than this withdrawal speed, so that there will be no crack in the ingot occurs or any transverse cracks will occurs, and a solid product without any defects we will get. That is the main things. That is called negative stripping. Negative stripping of the continuous castings, where the mold this and this movement of this and movement of this. So this is always, it is downward speed should always greater than the withdrawal speed. If it is reverse, if withdrawal speed is less than this mold wall movement, then the crack will occur in the ingot as transverse crack, which is a defects in the your product. So always this downward speed should be maintained, such that that is called your negative stripping. So in this process, the ingot is your form. Ingot is continuously go on, and it is cooled in secondary cooling, then cutting, and then supply to other area. And different product generally in the modern advance in the Japan countries also, they are directly forming the no bloom, no slab, they are forming direct plate, sheet, we can even coil, all these direct finished products. So we will totally rolling mill concept which is removed, and the cost of production is now they are competing with the others to give the metals in a lower costs. So there are three types of your continuous casting machines. One is your vertical type, another is one is vertical type casting machines, another is vertical mold and horizontal discharge, and another is S type, and curve will be like this. And in this way different, this is S type means it will be like this, and horizontal means direct, vertical means direct, metal will be discharged this side. So in this way there are different type of continuous casting machines, then we will got product in different way. But in the vertical, the shop floor will be more height, In vertical case, it is as the shop floor will be around third floor, fourth floor. So to maintain the low height, we will go to the S type. And similarly, we can take longer distance and height is small. So we can cast into different product. Nowadays, all are cast into this continuous casting machine. Or this is also more advanced, and this give good process. So this is all about this continuous casting, its principles, its advantage, and this mode, and all discussions of this. So thank you all students.